guys, I'm Fraction Frank, and today we're investigating benchmarking and residual thinking. What do these terms mean? Benchmarking is like estimating, but we use it with fractions to compare the fraction to a number we know. Let's revisit how we might estimate with whole numbers. We're given the equation 493 plus 132. One way you might estimate the answer is to say 493 is close to 500 and 132 is close to 100. So by adding 500 to 100, we get 600, which should be close to our actual answer.
Let's look at 3/8 and where this sits on a number line. You might notice that this number line doesn't just use whole numbers, but instead starts at 0, then goes to a half, then to 1. To find where 3/8 is on our number line, we must first divide our 1 whole into eighths. When we look at 3/8 on our number line, you might notice that it is slightly less than a half and closer to 0 than 1. Let's look at this in a different way. Let's imagine our circle as a pizza. First, we must divide our pizza into eighths before shading 3 of the eighths. Again, you might notice that 3/8 is slightly less than a half, making it closer to 0 than 1. 3/8 is the proper fraction, which means its value is less than 1. Let's now look at an improper fraction, which means its value will be greater than 1, but not a whole number.
Let's look at 13/8. This time, because our improper fraction is greater than 1, our number line ranges from 0 to 2. Firstly, we must divide each whole into eighths. Even though we get to 8/8, which is equivalent to 1, we must extend past this as we're working with an improper fraction. We can now see that 13/8 lies between 12/8 and 14/8. You might also notice that 13/8 is closer to 2 than 1. Let's look at representing this in a different way, this time using rectangles. To find 13/8, we must take our rectangle and separate it into eighths. As we colour in the eighths, you'll notice that we have fully coloured in one rectangle, however, we have only represented 8/8. This means that we need another rectangle which we can colour in our 9th, 10th, 11th, 12th, and 13th. This shows us that 13/8 is the same as 1 whole and 5/8, which is also known as a mixed number.
Benchmarking can be very helpful when we compare fractions. Another useful strategy we can use is residual thinking. Let's use the strategies we have just learned about to compare 4/5 and 7/8 and see which fraction pair is bigger. Let's look at our number line. On the top section, we have divided our whole into eighths. Using benchmarking, you can see that 7/8 is very close to 1. Under the number line, we have divided our same whole into fifths. You can see that 4/5 is also very close to 1. However, when we look at our fraction pairs, we can see that 7/8 is closer to 1 than 4/5 is, therefore making it bigger. We can also compare these using our rectangles. Our first rectangle we will divide into eighths and shade in 7 of these eighths. Our second rectangle we will divide into fifths and shade in 4 of these fifths. Using residual thinking, we can see that 1/8 is smaller than 1/5, therefore 7/8 is slightly larger.